I'm only here for the socks, and Edgar was so excited that my feet size is 46, so at least something good. So, welcome everyone. I'm excited to be speaking here. This is my second time in Riga. I liked it so much that I came back again. I'll be talking about traffic routing with Istio. I've never seen a Victor stock before, but I think it's going to tie into it pretty good because I'll be talking about some of the things that he mentioned as well, but maybe not even go into. I'll go into more details than he went into probably. Quickly about me, I work at Oracle. I have this long title at Oracle. I'm currently at a team that's called the A team. Previously, I was working on a serverless framework called the FN project. I'm mostly working with the cloud native stuff, so any buzzwords that you hear, that's what I'm working on. I also wrote a couple of books, the latest one being on cloud native and Istio, and then there are some older books that I did years and years ago when I was at Microsoft. I also tweet on Twitter, so feel free to follow me, or not, but if you do, you might get some prizes. No. All right, so I usually ask these questions, but I think everyone's familiar or at least heard about Docker, right? And then Kubernetes, some people. How about service mesh? Istio, okay, all right. So this talk will be mostly about service mesh. So what is service mesh? It's a dedicated infrastructure layer for managing service-to-service communication to make it visible, controlled, and manageable. So I'll be focusing on the Istio service mesh in this talk. There's other service meshes out there, such as Linkerd or HashiCorp's console, but I'll be focusing on Istio. Istio was created by Google with a partnership from IBM and probably other bigger companies as well. It's an open source product. And it lives on top of the Kubernetes and exposes APIs. You can also run it on VMs directly. You don't have to run it on Kubernetes, but I'll be focusing on the version that runs on Kubernetes. So that definition looks nice and everything, but let's go into the practical things and how does it actually work. So if you're familiar with Kubernetes and the pods, what Istio service mesh does, it injects a proxy next to your service. So you have a pod with your service container running, and what Istio does, it injects that Envoy proxy. So what does that proxy do? So the proxy intercepts all the traffic that's coming in or out of the service, right? So previously, if you had service A talking to service B, you would talk to them directly. With the service mesh and the proxies injected, it's the proxies that are talking to each other. It's not services anymore. And one of the nice properties about of Kubernetes pods is any containers that are running in the same pod, they share, amongst other things, they share network. Meaning, the proxy can talk to the service through localhost, and service can talk to the proxy through localhost as well. So what that gives you is all the traffic is intercepted, but it also means that you can learn something about the requests and the traffic, and that's what Istio does, right? So all the traffic that gets sent between services, Istio is using that traffic to extract some information, extract some metrics, and then make traffic routing decisions based on that. This model of deployment is also called a sidecar deployment. If you remember those old motorcycles that have like a sidecar next to it, that's where the name comes from, I guess. The other type of the deployment is called per host, where instead of having a proxy instance per service, you have a single proxy instance that's on a node, right? So you have multiple nodes in your cluster, and each node has one instance of the proxy, and the proxy and the IP tables and all the network magic is configured in a way that the services talk through that one proxy that's living on the node. So that's a better deployment if you're trying to scale out a lot, right? Because in this model, if you have 100 instances of your service, you're going to have 100 instances of the proxies as well. Finally, the collection of these proxies is also called a data plane. Welcome, Victor. The second part of the service mesh, if the previous one was a data plane, the second part is called the control plane. And this control plane is basically responsible for managing and configuring the proxies that are in the data plane. Makes perfect sense, right? So they're configuring components that used for security, for enforcing policies, for collecting telemetry, and for doing traffic routing as well. So I'll be mostly focusing on the pilot component, even though I won't be talking directly about this component. But the pilot component is the one that takes the rules that you define. Can anyone guess which format are the traffic rules and Istio rules defined in?
YAML?
There you go, yeah, well, everything is YAML in Kubernetes, so that was easy, right? So what Pilot does is Pilot
natively is JSON.
Well, it's JSON. YAML is a subset of JSON, right? Or vice versa. It's one of those things. But yeah, you never know which one is better, right? At least it's not XML. So anyway, what Pilot does, it takes those YAML rules and then it converts them to Envoy configuration files, pretty much. Well, actually, it holds an abstract model of those rules in its own. Like in its own storage, and then those rules are converted through the adapters. There's an Envoy-specific adapter, right? It converts it to the Envoy-specific configurations. It pushes them to all the proxies, and the proxies reload themselves automatically. There's other components here. Galley does the configuration validation. Citadels enables authentication, and it does identity and credential management. And then Mixer does enforces the access control and usage policies and collects all the telemetry data. So all the data that gets sent between the proxies gets collected by the Mixer as well, right? And the Mixer supports the adapter model. And without going into too many details, it's implemented in a very generic way, the Mixer that is. And it uses attributes and all the very generic-y stuff, so you can pretty much do whatever you want, almost, but it's very complex. Like you have to really wrap your head around the whole thing, but it's extremely extensible. So if you put these two things together, you have your data plane at the top with your proxies talking to each other, doing policy checks and telemetry checks with Mixer, and then the control plane at the bottom. So what are some of the benefits of using service mesh? There's a lot of downsides as well, which of course I'm not going to talk about, right? I'll only talk about the good things that you can get. If you think about the buzzwords of cloud native and microservices and serverless and functions, there's a lot of moving pieces, right? Usually in the monolithic world, you had a couple of components, a couple of applications. In the microservices world, you have a lot of these things, right? And managing the communication and actually getting the visibility into what's happening between those services, right, is one of the benefits that the service mesh can give you, right? It can give you the visibility into the communication that's happening between your services. Once you have that visibility, what you can do is you can use it to your advantage and then do percentage-based routing or do routing based on request properties, right? And Victor mentioned that. He was mentioning Canary and doing the percentage-based and then doing more advanced routing, if you wish, on request properties where you can say, if the header ABC is set or if the header ABC has value blah, then I want to route to this version of the service. Or if the scheme is HTTPS instead of HTTP, or if the URI matches this or that, you can do a lot of traffic routing based on those properties. And it also, Istio and other service meshes, they also have a well-defined API, meaning that you can easily automate it and write tools against it. Knative is one of the things that was written on top of Istio and it uses Istio. Right? Finally, it also allows you to push a lot of your network code that you might have had in your components and your services, like doing retries and timeouts and circuit breakers. You can push those things out of your services and let the service mesh handle it for you. Any questions up until now? This was like a slight intro. All right, so let's get into the actual traffic management resources that are used in Istio. And these are the 4 resources that you can use to deal with the traffic. The first one is the gateway, virtual services, destination rules, and the service entries. So I'll go through all of these through some demos, and I'll explain them as we go along. But these 4 plus there's a sidecar resource, which I'm not going to talk about. But if you want to do any traffic routing with Istio, these are pretty much the resources that you'll have to master and learn about. So the first one is, the first resource is called the destination rule. So what you can do with this resource is you can split your Kubernetes service into multiple subsets, right? In this example, I have my greeter service that's running in Kubernetes. I created 2 subsets, and I sliced my Kubernetes service into version 1 and version 2. And then I defined some labels underneath those subsets. So this is like a simple split by version, but this is completely configurable, and you can split it any way you want, right? So you can say, instead of using versions, you can say I have a production and development subset of my services, or I have testing and staging, or of course I'm blanking out on any other examples, but usually it's version names, right? Or you can even do blue-green, but I'm not gonna talk about that because Victor. The next one is the next resource is called the VirtualService, and this is the resource that you really have to master, and then most of the settings are actually defined within this resource as well. So if you go and read through this, what we're saying with this service is, with this virtual service, that we have a single route, but then underneath that route we have 2 destinations of our service, to the service. One is subset V1, which is, if you remember from the previous slide, that subset that uses a label called V1. And I'm also setting a weight there that says, I want 98% of the traffic that comes into the service to go to that subset V1. The V1 subset of the greeter service. And then at the bottom I have the remaining destination, which is the same service, but a different subset with a 2% weight on it. So this brings me to the first traffic routing pattern in Istio, if you wish, which is called percentage-based traffic routing. And the idea here is that you're basically directing your traffic, your incoming traffic, to 2 or more versions of your service. So in the simplest example, you have a 90-10 split, but you could easily have like 80-10-10, or pick up the numbers, whatever you want, right? And then make the split between services based on that, right? What this allows you to do is it allows you to release the services with minimal impact. This is not fully automated. Like Victor was talking about, very automated, ideal world, in my opinion, right? This would be something that you would apply. You would apply a resource that does the split like this. You would go and you would monitor your services. You would make sure that there's no bugs, and then you would gradually increase this percentage to the V2. Once you reach 100%, you can remove the old version and you're done. In the ideal world, this is all automated, right? Where you're monitoring the services, you're monitoring the metrics, and then making decisions based on that. And this also allows you to do a simple rollout rollback, right? Because you're just increasing the dial left or right depending on your results of your testing or your metrics.
Is there any UI for that? Or increasing, decreasing?
So there's with Istio, you can install, or there's a dashboard called Kiali, or a tool called Kiali that actually gives you a slider where you can move it left and right, and it's going to create these resources behind the scenes, right? And it's nice, but I think practically all this would probably be automated somewhere, and you wouldn't be manually doing this. But it is nice. It looks nice, and I'll show you a demo. I especially like the feature where they show you how the traffic is flowing to different services. But yeah, there's a UI for it. All right, well, first demo time, there you go. So I have a very simple service. Well, I have two services. I have a service called Hello Web, which is just a simple front end written in Node. And then I have a greeter service that basically returns a greeting to the web and it displays it. So what I'm going to do is, I'll try to do a 90-10 split and send 90% of the traffic to the first version of the greeter service and then 10% of the traffic to the second version. So I go to my terminal and my cheat sheet. All right, so I have Istio installed. I'm just going to go and install a bunch of things here, and then I'll talk through it. So I'm installing my Hello Web. I'm installing both versions of my greeter service. I'm installing a destination rule. I'm installing a virtual service for the Hello Web, and I'm installing a virtual service for the greeter service that routes all the traffic to the V1 version of the service. So as soon as this is done, I guess this is done. And I'm running this on a live cluster, so fingers crossed. Hopefully it works. Yeah. So I have my two versions of the greeter service. I have my Hello Web. And then let me show you the destination rule. This is the same thing that you saw on the slides. So I have a V1 and V2, which just sets the labels of version V1 and version V2. And by the way, these are the labels that are set on my deployments. That's how Istio figures out where to route the traffic. And then let me show you the greeter vs all V1. I have a single destination here where I'm saying all the traffic is going to go to the subset called V1, right? So I have this deployed, and let me just get the IP address. Is the font size okay? Good. All right, so this is my IP address. Of course it's that's my luck. There you go.
What?
No, it should be. It is 8080, but there you go. It was HTTPS. So this is my awesome website. This is the front end, and this message down there, hello, and a wavy hand, is coming from the greeter service V1, right? So if I go and just reload as many times as I like, I'll always get this because I'm routing 100% of the traffic to the V1 version. So let's go down here and I'll just, oops, go here, just do a split. And I'm just going to make a bunch of requests as soon as my terminal comes up. Just making a bunch of requests so you can see that the response is hello. And next thing that I'm going to do is I'll do a 90% of the traffic to V1 and then 10% of the traffic to V2. So I'm just going to apply this. Rule. I might have to do 50-50. Oh, there we go. Well, you already saw like one pop up, which was the second version. And the same thing here. And I just refresh a couple of times. It should show up. If I talk for long enough, it'll probably show up. There you go. It was there. You saw it. I was good for you. You believe me, right? All right. Let me also show you. So I'm using a cluster that's running on Oracle Cloud. You can use any other cloud provider that you wish. You can do the exact same demo. And I have Istio installed. Let me just show you a couple of tools that get installed with
HTTPS.
HTTPS again? Probably, right? No, this one takes a little while. There you go, yeah. Username and password is admin by default, by the way, so just in case you forget. Yeah, so this is this nice thing that I wanted to show. It's very
Is it open source?
Kiali is open source, so I think everything is open source. Except
It is.
for Grafana, probably.
Okay.
Oh,
Grafana is open source as well.
Yeah.
There you go, everything. There you go, this is the cool demo. Where you can see, this is nice, this is how you can visualize like your traffic and your services in different versions and
If you go up
everything.
and edge labels, then you can show the percentages.
Oh, true, yeah, you can also show the,
Is the traffic actually based on reality or it's just random animation?
I don't know.
Seems
No,
like
I mean, it's,
50-50, but
like, this one is saying 84.7 and 15.3, so I'm assuming if I run it long enough, it
One
would
thing
be
is divided into two.
90-10,
yeah.
right? But yeah, I don't know how they, like, it does take, they do some math to figure out, like, where to send this stuff. But the animation itself, that's like, it's constant, right? The percentages are what matters, right?
Well, there will be a delay because the Envoy proxy does buffer, it doesn't send every
Yeah,
down,
it
and
does
so it
sampling.
buffers it and before it sends it down to the mixer.
Grafana, anyone use Grafana? Yeah, so this is all, like, the nice thing about this is, like, it's all out of the box, like, I didn't have to install or create any of these dashboards or anything. So you get all these nice things automatically. All right, I'll stop this just so it doesn't, so it can scale down. So this was the 90-10 split, and then the second one is, the second way that you could route traffic is based on the properties of the incoming requests, right? So since all traffic goes through like those proxies, you can use that to inspect the request and then make the decisions based on that. You can use this for Canary, you can use this for A/B testing, like whatever your heart desires. And I'll go right into the second demo right now and show you how you can use a user agent header to inspect if the traffic is coming from an iPhone or an Android phone, and then based on that, you're going to route the traffic to one or the other. So let me go back, more demos. So I'm going to leave everything, like everything deployed, I haven't touched anything, and I'm going to show you the, we have like iPhones and Androids in the room, probably, right? So this is a very simple routing rule that I did. What I'm doing here is I'm saying I want to match the incoming request headers, and I want to inspect the user agent header and say, does that user agent header conform to that regular expression over there, which is extremely simplified, right? But it's basically saying, is it an iPhone? If it is, then let's route the traffic to the V1 version of the service. And then similarly down here, if that matches a false, oops, if that matches a false, I'm going to do a check for Android, same thing, and I'm going to route to the V2 version. And then finally, if I'm not on Android or not on iPhone, I'm on desktop or whatever, I'm just going to go to the V1 version. So let's deploy this one. So apply here. All right, so this is deployed. So now if I go to my browser here, I'll always get the V1 version no matter what, right? So if you wish, feel free to scan this guy here, zoom in. And then if you have an iPhone, you'll get, I think, V1, and if you have an Android phone, you'll get a response from the V2 version.
Xiaomi.
Sorry?
If you have Xiaomi, you go to iPhone.
No, but this, I mean, it's a demoable thing that's very nice to demo, but does it work?
Phone do you have?
I got hello on iPhone, is it okay?
I think so, I don't know, let's see. So, iPhone, you're supposed to get V1.
V1,
Yeah.
Okay.
And on Android, you get V2, which is
Yeah.
the fire emojis, right? And on whatever third version of the phone is, you'll get the V1 as well. So, but yeah, you can imagine doing this with either, I don't know, you can route traffic based on if your users have signed up for some beta features, or if they're logged in, or if they're developers, or, I mean, there's endless possibilities that you can do here. Yes?
What about time like regex can be time consuming, and we are, if for instance we have regex and cookies, and we have a lot of cookies.
So there's a way that you can do, you don't have to use regular expressions, you can do exact match, or you can do a prefix match as well, if that's too consuming to calculate.
Okay.
Right? There's 3 ways that you can match.
But do you have any experience like how it can impact really?
Practically, what's the actual like latency that this introduces?
Yeah.
I don't have any numbers, no.
Okay.
Yes.
I'm just curious, what's the advantage of using this method of routing instead of just plainly, simply putting this logic into an application?
That's the point. That's the whole point.
That's the whole point, that you're moving this out of your application. Right?
Yeah, but that's application logic, isn't it?
Well,
A/B testing.
not necessarily. It could be, but not necessarily, right?
So is networking the application logic?
I have another question, which is
But this is
actually in
pure
addition to
networking.
this
Yes,
one.
it depends on
Why
the
to move
application.
it, okay, from application, we try to put it one level up, right? But why we actually put it so low? Why don't we put it on the CDN level where it belongs to?
That's a good point.
I
as
mean,
well. Yeah.
that's where the whole Lambda at
Yeah, I
edge
mean,
started.
yeah. The other thing, like CDN, sure, but this is actually inside your cluster. This is not necessarily, like, these are services they're running like behind your inside, right? Not necessarily exposed to the outside, right?
But in this situation, you check regex user agent, which is known just
Sure,
on
yeah.
CDN level.
Yes, yeah. But you could do
At the
multiple.
same time, in our reality, like in my company, it would be very hard to change something on the CDN level, but in my small application,
you can do
it's
it.
up to me. Yeah.
I think it depends on the scenario, to be honest, right? It's.
But, going back to your example, if it would be an application level, then you wouldn't be able to decide whether to forward to version 1 or 2.
That's true, yeah, because you would hard
Because
coding
it needs to enter the version 1.
Yeah,
and
yeah.
then-
We will build this future.
Yeah. I mean, the thing is, there's multiple ways to do all these things, right? Like service mesh is one way to do traffic like this.
This one allows doing changes ad hoc as well.
That's true, yeah. Like this is all without code changes, right? I don't have to rebuild anything. I don't have to push any code. I mean, you should still probably have your configuration somewhere.
Can you add headers with this thing?
Yes, you can add headers as well, and you can say when it goes, you can do a match, and then you say add headers, and I think even remove if I'm not mistaken. So you can do a lot of
Can
a lot
I
of them.
rewrite status code?
Yes, you could. No, the status code. So there's one thing that you can do is you can use, and I'll talk about it on Thursday, I think. Tomorrow as well, but on Thursday as well. Yeah. You can do fault injection, meaning you can say, I want my greeter service to return me 404 for 60% of the requests that are coming in, or for 100. Doesn't matter, right?
In my case, I needed the opposite, like, so this was repeated 404 with proper HTML inside. That happens sometimes.
Yeah.
But so actually everything works fine, but for some reason I have 404.
Yeah. Yeah, you can, I mean, you can inject, like you can do delays, where you can say, before this service responds, wait for 6 seconds or whatever, right? Or you can do like aborts and say 404, pick a status code, right? And then return.
So these regex expressions which you've shown, they are static, right?
Yes.
So that's the biggest problem, where, like in my case, I had a customer who wanted to verify that customer ID is actually in the database.
Okay.
So if he is in database, then go to
It's
V1.
authorization. It
If
shouldn't
he
be-
is,
Oh.
if this ID is not in this database, then go to V2, for example.
Yeah, that would be a bit more,
But in that case-
unless you're rewriting the.
No, so what I end up is I generate this regex dynamically.
Yeah.
Paste it.
Yeah, there would probably
Once
be
around.
a different,
No, but that's what we can do in this case. We can
With
just
the position is all
Yeah.
I want to hear what he's saying.
No, in order to solve this problem, you can just place on top of it some kind of proxy service which takes this ID and enriches the header and pass.
Or just,
And
yes,
pass it
add
as a
another.
real service
Yeah.
for this decision.
You can add an envoy filter.
Oh, like your own and then make it calculate.
Yeah, but luckily I'm not using Kubernetes in any of my projects, so I solved it using Lambda at Edge, and there I just use my regex expression, which I compile once an hour.
Oh, yeah, yeah.
So for me it worked similar to what you would say. So Kubernetes didn't help.
Well, Kubernetes is like, it's not every, it's like a hammer, right? It's a tool. It might not work for everything, even though it should. All right, so this was request-based. Another nice feature of
Just on that request base, you can do that in Kiali as well. If you
Oh,
want
yeah.
to do the UI.
Back to your question, yeah, let me, sorry, I have some time, right? Just at least a little bit. Let me show you. Go here. Hope I didn't lose the connection. No. Was it here or was it services? Here? Ah. I'm losing that. Virtual service. So I could delete this one, right? And I could say, where's the new one, Sherwood? Where can I create a new one?
You just go back to VirtualService.
Oh, just the service. Yeah, I don't have it. Maybe here, right? Hopefully this will load. Of course it's not going to work, right? You'll have to believe me, there's a UI.
Yeah, I do.
You do? Perfect, yeah. You might get a t-shirt. All right, so, whoops. So another feature is called traffic mirroring. Sometimes this is also called dark traffic or traffic shadowing. And the idea here is that any requests that are coming in, let's say to the V1 version, you're saying, I also want to duplicate that request and send it to this other version of my service. And this is a fire and forget, right? It's not being tracked. There's no impact to the end users, at least not in the functionality, right? What you can do is then you redirect it to the second version, and then you can basically either test your services or do debugging, which I don't suggest, but there is a way to do it, where you can say, you can have version 2 of your service running locally on your machine, and with some ngrok magic and some magic of Istio resources, you can make it redirect the production traffic that's going to V1 to duplicate the traffic to go to V2, and then to proxy that traffic locally to your computer, and you're going to hit the breakpoint in your editor. I don't suggest you doing that, but you can do it if you want to.
I have a question, a really short one. Does it work with TCP and UDP or just HTTP?
I only tried it with HTTP. I don't know if it works with TCP or UDP. I don't know.
Okay.
It might. Tried it with HTTP.
Why not?
There you go. Yeah.
Rerouting production traffic to some other place is not good. It's production data and a lot of potential.
Of course.
A lot of risk.
Yes.
But
Yeah.
it cannot work with TCP because TCP doesn't have headers, so there is nothing really for you to make a decision.
Route,
Yeah, maybe.
So let me, the debugging scenario that I said, I mean, it was, you can do it, but that doesn't mean you should do it, right? There's a lot of things that you can do, but it doesn't mean that that's a good idea. So let me show you the mirroring really quickly. So this is how you define it first. So I have the same route, one destination, 100% of the traffic going to this one. But then down here, I'm also saying I want to mirror that same request and send that same request to the V2 version of the service. So what I'm gonna do to show you this, I'll delete the V2 pod so we can look at the logs. This. So I deployed it. So I'm just going to follow the logs from, there you go. So there's no logs, right? No requests being sent. So if I go to the browser and I refresh, I get a response back in the browser from V1, right? But I also get you can see the request was being made to V2 as well, right? So you can imagine you could test stuff out if you wanted to, or do that thing that I'm not going to talk about. But it's basically duplicating the same request, firing it, and forgetting about it, right? So don't, like if you're going to do this, actually be very, like think about what happens when you fire that request when the request is duplicated, because if it's going to go to the database, do some writes or whatever, like be careful, right? Don't just blindly do it.
Can you make a loop?
To make a loop of what?
Just request being sent to the same one.
Yeah, you can do just while and then do a loop like that. But
No, I mean V1 send request to V1, and then it will multiply itself.
probably, yeah.
Like fork one.
You could probably do it. Yeah, I haven't tried, but you might be able to do it. Yeah. The worst case, you're going to get a 503, and Istio is not going to know what to do. So, but even worst case, you get what you said. All right, I don't know how I'm on time because my timer didn't work, but so I'll talk about a little bit about the Ingress as well. So the Ingress resource is used to, well, the gateway resource is used to configure the incoming traffic to the service, right? Traffic that's entering. And with the default installation of Istio, you also get a gateway that gets installed, the Ingress gateway, which is the envoy proxy pretty much. And then you can use it to route external traffic that's coming to your cluster to the services that are running inside of your cluster. So here's an example where you would use a gateway resource to configure where traffic gets routed, where the external traffic gets routed within your cluster to which service. Here's how you could define it. We can basically say you have a gateway, and the selector, which is selecting the instance or the pod of the gateway, and then you're saying for all the hosts, this is the Ingress gateway. And then in the virtual service, you're basically saying, I want to attach this virtual service to this gateway, which pretty much makes it accessible from the outside. And in the practical world, instead of that star down there, you could do mydomain.com, right? And then you can use that to create an A record to your external load balancer, create a CNAME to that one at your domain registrar, and then you can use it to, anyone who goes to example.com will be able to go through this gateway and hit your virtual service or your actual service. And then similarly, you can also define an egress gateway or a gateway for any traffic that's going outside of your cluster, not just going in, but going outside. With this, there's multiple ways you can do it. So on the left side, we're using a service entry resource to define an external service and make it part of your mesh, like bring it in. And with that, what you can do with service entry, if you add the virtual service on top of it, you can do all the traffic routing, you can do failure injection for the external services, pretty much anything that you can do for your normal services that are inside your mesh. And then additionally, if you're in, I guess, more secure control environments, or if you want to control traffic that's going out, you can also say, for any external service, I'm not going to go directly to that service, I want to route the traffic to an egress gateway as well. And that way you can then create metrics and all the stuff to monitor any outgoing traffic if you need to do that, right? It's gonna be slower, right? But if you need to, you can do it. And then, in the original versions of Istio, any external services, but were not accessible by default from within your cluster. So if you had a service that was calling to the GitHub API or something, it was automatically denied. The services could not get access to it. That's the whole reason they created the service entry, where you can actually explicitly say, I want to allow access to api.github.com, and then you can use it like that. Yes.
Yeah, but still my pod can communicate with internet like directly.
No.
So it kind of enforces?
Yes, because it goes, remember, it goes through the envoy proxy. So everything that you talk, everything from your container, right, from your pod,
Yeah.
from your container within the pod with the proxy, any communication will go through the proxy.
But it should go through the local host, right?
Through the proxy that's running.
Yeah, but if I like communicating directly with some IP address, external one,
But
so
it's
will
still
be,
gonna go through.
so it's kind of
So, yeah.
like
it's-
under the hood how it works. It kind of some IP tables rule.
Yes, yeah.
Okay.
Yeah, it hijacks all the, like, it
Yeah.
does the IP tables and hijacks all the, so anything, you cannot access google.com, for example, if you lock it down, right?
How does it work with HTTPS then?
The same thing.
As like, if I want to access the, let's say, HTTPS google.com, so the envoy will somehow disassemble the SSL?
You can do there, so there's mutual TLS that you can do between services, and it's not gonna, you're not gonna be able to access it from the inside unless you specifically say service entry. It uses the secure naming or something policies to figure out where it goes, right?
But you can always reach by IP, right?
No, it's still not gonna work, right? Because it's blocking anything that's out, anything that's not in the service mesh registry. It's gonna block it by default.
So kind of forwards.
If you enable it, right? It's not enabled by default right now. It was,
Okay.
right? Right now, if you install it, it's gonna work. You can access whatever you want.
You
But if
should
you
add an
wanna,
annotation to switch it on.
yeah, exactly. It's a
If
configuration.
there is no
setting.
annotation, then it goes.
Yes,
other
yeah. So by default, it's saying allow any.
It's a
right?
global policy that Istio sets up when you install it. It automatically sets.
Yes, yeah. It's
So
set
if
it
you want
for
to lock it
anything.
down, you would have to remove that policy, and then you would have to create the service entry.
Yes, for all the services that are out external to your cluster.
And then in the service entry, you could specify that it's HTTPS and all that, and then.
Yeah, to get the access to it, but it's
Right.
blocking. It was, that's
The
what
question
the.
about HTTPS was more about certificates.
Yeah.
You need a secret part of the certificate, and you cannot obtain Google one. So your service, it's kind of in the middle attack, you know. You need to provide your own HTTPS certificate to be able to do it, and you should convince your service to trust your.
Yeah, so they have their own certificate, so Istio will inject all the certificates for your service.
Okay.
Right?
Okay.
It does all the, it has all the certs in there. So where to get started, or how to get started actually, if you're planning to start with Service Mesh, chose just one feature, like pick one. Pick one and get started with that one, don't go like all aboard with everything. Learn the basic building blocks, learn the resources, VirtualService is the one. Choose your services that you're going to apply the Service Mesh features on. Do a lot of testing, and then rinse and repeat if you want to expand and adopt more features as you go along. But just like with anything new and shiny, start very small, test it, and then go along. Where to start? I work at Oracle, so Oracle Cloud. Kubernetes IO, Istio IO, and then Istio documentation is pretty good as well. They have a lot of examples. Yeah, I don't know if I'm out of time or not, but I'm going to think I am. But yes.
I think you mentioned at the very beginning console. Can you just briefly explain what this versus console connect?
the differences,
Yeah.
or, so Istio was built more for Kubernetes, I think. It was Kubernetes first, but console is, I mean, I don't know a lot of details about console, but I think console gives you more flexibility on how you set it up.
The Console Connect is exactly a solution for service mesh.
Yes.
So from what I understand, this is literally one-to-one match. I thought maybe, you know, like, what is the difference?
They're all the service meshes are becoming one-to-one match.
Exactly.
At this, yeah.
So
Yeah, Linkerd is catching up.
Linkerd is catching
Yeah,
up.
Yeah, it's catching
It
up.
just started later, but
Yeah. Yes.
So, so I guess to continue this question, so do you have maybe some data or empiric evidence about what is the winner in service mesh wars?
So, yeah, I mean,
I can tell you it's not console.
yeah, well, I don't know, it's,
The traffic is the latest one.
I think it's
No, traffic is not service mesh.
No, they recently
traffic,
told me something.
traffic?
Yeah, something non-invasive.
Yeah,
service
I
mesh,
saw,
something
yeah, I
like
saw
this,
that, yeah. I think it's gonna be probably a couple of more years before like a clear winner is announced. I mean, Google is backing Istio,
It's
right?
gonna be Istio, that's the given.
Yeah.
Yeah, but
I think a lot of people are betting money on Istio. But then you have companies who are betting money on the service mesh interface as well, and just saying, well, we're just gonna use this interface and it's a generic and you can use any mesh you want behind the scenes, but
When you
I
mentioned,
think it's similar conversation like we had Swarm, Nomad, Mesos, Kubernetes.
yes,
Just by the sheer volume of adoption,
it is Istio.
Istio is likely a winner. It's not a question what is better, what is worse. It's simply, it's being backed, and if you look, Google is contributing heavily, Red Hat is contributing heavily, I don't know, you guys, we are contributing kind of like, the sheer volume is what makes it a winner.
Yeah. And there are like a bunch of, and not that that matters, but there's a bunch of startups like betting money on Istio as well, right? So I don't know. I'm always cautious when making predictions like, oh, it's going to be this, because it's never that. But so far it looks like it's Istio,
but maybe there's a different paradigm, and there needs to be a paradigm shift about current implementations of service meshes. Maybe it's something different.
so if you build on OpenStack-based cluster, then Istio will work as well for like as a service mesh for.
Doesn't
OpenStack.
matter. If you have Kubernetes, Istio
Yeah.
works.
No Kubernetes.
I don't know.
Exactly, but you can use console for OpenStack, managed cluster.
yeah,
and
probably,
OpenStack.
yeah, probably.
The
So
thing is that-
so it's a tool for a tool.
So that's. Oh, sorry, I'm taking
No, it's
over.
fine, it's fine. Amazon also has their own managed service mesh that they came up with, right? So they have a horse in the race as well.
But is it forked from something which is an open source?
there's a
service?
void.
I mean, it's Envoy, like everything is pretty much Envoy based these days, right? I mean, not everything, but it is Envoy based, but it's not, they're not saying it's Istio. I don't think it's Istio, right? It's
It
whatever.
has very strange name, service mesh,
Yeah.
name of the service.
Yeah, it should be something like letter and the number.
And the last year.
All right, if there's any questions, I mean, I'll hang around for a little bit. Thank you very much.